Okay, welcome everyone. This talk will be a bit different, I guess, than the talks that we saw just previous. A little bit of change of pace. No marketing, but more a deep dive into NLP and NLG. So yeah, my name is Sander Wubben. I'm a co-founder of Flow AI. A little bit about my background. I studied computational linguistics, which is another word for natural language processing. I then obtained a PhD in natural language processing and more specifically natural language generation. And from 2012 until now I've been connected to Tilburg University as an assistant professor, and I'm also the co-founder, as I mentioned, of Flow AI. Flow AI is headquartered in the Netherlands, actually, and we are a conversational AI platform. Basically, we have a nice drag-and-drop interface, but we are powered by powerful NLP, and basically we combined it into a platform, and that is Flow AI. Let me skip this. So basically how it works is, as you've seen with a lot of the other platforms, we are in between the chatbot and the channel, as you could say. So we are a multi-channel platform. You can connect to Facebook Messenger, your own website, your app, Google Home, Alexa, or WhatsApp, or RCS, all these kind of channels. We all support them all. And we also support the capabilities of handoff scenarios. So it's been mentioned once before today, but I think it can be mentioned enough. A lot of the customer service chatbots can only really be successful if you combine them with human agents who can take over if the bot doesn't know it, or if some more complicated scenarios are required. So you can all design this, train the AI, connect it to channels, connect it to services like Dashbot, and basically have the complete solution in our platform. So today I wanted to talk a little bit about types of chatbots and the kind of technology that you could use to build these chatbots and that you might see in the future. So if you look here, we see a couple of different NLP-based chatbots. So luckily today all chatbots use some kind of NLP, I guess, unless it's only buttons and images. But if you look on the left side of this diagram, you see the retrieval-based chatbot. And I think that most of the chatbots that are in existence right now can be considered retrieval-based chatbots. And what I mean with retrieval-based chatbots is that you have some kind of query, you do a classification on the query, and you try to find the query that is like it matches it best, so the intent of the query, and then you perform some kind of action based on that intent. Now, of course, if your bot is in an open domain, that's really hard, or it's actually impossible because you can never have scenarios for everything that can ever occur or everything that someone can say. So if you are in a closed domain, it's a lot easier. So if your bot is a recruitment bot, or you are in the marketing or in customer service for specific brands, that's a closed domain. There you can handle the questions that are coming in best. And then if you look at on the right-hand side, you see the generative chatbot, and that's something I want to talk about today. And that is a chatbot that doesn't do the classification, so it doesn't try to find the best matching intent, but it actually generates a response based on the input that it gets. And I would say it's more human-like because it's more like the way that we do it. Like if I respond to someone that says that talks to me, I generate my response, right? I generate real-time text, basically. And of course, in the future, we would like to have chatbots that can also do this, because if you have chatbots that do that, you can do personalization, you can have more human-like conversations, and have less canned-like responses that we usually have now. So if you look at a chatbot architecture, what a chatbot looks like, so if you look at a complete voice experience, then you have a person that generates some kind of audio wave, some kind of smart speaker like a Google Home that records this speech. It translates the speech into text and then does some kind of understanding, machine learning on the text. Has some kind of management system that does some dialogue management. It generate some kind of response in some way that is transformed into speech, and then the bot can respond, and then you have the full circle where the human responds, etc. Now, of course, if you have a chatbot, you can sort of ignore this part, and you only have the natural language understanding, dialogue management, and response generation. And that's basically what this is. So you have some kind of input from the user, you have some natural language understanding module, and then you know what the intent of the query is that you just saw. You need to do some kind of state tracking, so you need to know where in the conversation you are. So if you say yes, okay, we all know that's an acknowledgement, but what are you actually saying yes to? So you need to look back into the previous part of the conversation, what actually was being said before. And then if you do that, you know the user intent, like for instance, the user wants to book a flight or something. And then you have a certain set of rules or some kind of system that checks what the policy is for that intent. You connect to your own systems, your databases and your APIs and whatnot, and then you can respond with some kind of action, generate it, and you're back to the user. So if you take one step further, then this is what this would look like in a full system. So you say, I want to book a flight, for instance. Then you do the intent classification. You figure out what the user is saying. You extract the entities, like the place you want to fly to, etc. Then you can have some meta information, like what kind of channel are you on, what is the time, what kind of information do you have about the user. And then you have some kind of system that does that is the policy manager, basically. This can be a rule-based engine, or you can have some kind of neural network that makes decisions based on historical data. So you predict an action, you take the action, and that can be like an API call, or you can send a response or whatever. So this is basically what chatbots look like if you look at the entire architecture. And of course, there can be differences in certain components, but this is usually how it works. So yeah, one of the main components of chatbot is natural language understanding. So it's a classification task. So here you see images, and here the task is, okay, which of these are, I guess, bagels, and which of these are dogs? And so does anyone know let me see, what this one is? Is it a dog? Who thinks dog? Who thinks bagel? Okay, good. Or is it the donut? Yeah, you probably know better than I. And this one is a dog, etc. So we know, of course, that this is a dog and this is a bagel because we see some certain features like a nose or an ear or something like smoothness or color. And of course, these are the features that help us classify these images. That's also how computers do it. So they need certain features to do classification. And for text, it's basically the same. So if you look at texts, like these are some utterances that you get into your chatbot, and these are some others. And you want to sort of do the classification that this is utterance 1 and this is utterance 2, or intent 1 and intent 2. So you need to sort of find the distinction there. And this is a typical machine learning problem. So you give it training data, you give labels, you give utterances, and you train the system. And then when it gets a new utterance, it does a prediction based on the features that it extracts, and it labels it with the right intent. So this is how all the chatbot classification systems work. So this is intent classification. And then you have something like entity extraction. So you extract, like if I say I want to travel now from New York to Amsterdam, and maybe you have some entities like the date or the time, departure, destination, and an intent that is travel advice. And of course, you can say it in all kinds of different ways. So that's why you need to train your chatbots with lots of examples. So that's natural language understanding, and that's, I think, pretty well defined and pretty well known by now. Certain technologies have helped us do this better, like word embeddings. But now I want to talk a little bit about natural language generation, so which is on the fly generating a response. So we have one good example, I think, from Microsoft. Are there Microsoft people here? I think so, right? So this was Chatbot Tay, which was released on Twitter at some point. And the fun thing at the time, I think, was for Tay is that you could actually talk to it, and it would learn from the dialogues. So that means that that actually people could actually train the chatbot online. So this chatbot was removed pretty quickly because it started having all kinds of racist responses to people and etc. And the reason was that, of course, if you let people on the internet do stuff, then at some point they were going to try to break it. So lots of people were teaching actually this chatbot to be racist and have all kinds of nasty comments. And of course you can learn dialogues from all kinds of data. So from film scripts, chat data, forum data, or from Twitter data. But of course, yeah, if you put garbage in, you get garbage out. So it's very important to know what kind of data you enter in your system. So how does it work? I'll not go too much into details, but the technology behind these kind of systems that learn to generate text are neural networks, and more specifically recurrent neural networks. And recurrent neural networks are neural networks that actually work sort of in a fashion that it takes their own output as input for the next step. So it's a recurrent process where you can have several different time steps. And at each time step, you can make a prediction, and then at the next time step, you take that prediction and you predict you make a new prediction. And that's basically how we generate languages, how we generate language ourselves. Because if you think about language, it's something that sort of occurs through time, and which is like every word that I say is sort of depending on the word before it. So you enter something like "How are you?" Into the network. The network learns some kind of representation in the encoder, and then in the decoder it tries to decode it into a response. So "How are you?" there is encoded in some kind of representation, and then it decodes it into "I am good," which would be the response. And this is trained by giving it lots of examples of parallel data of like an input and an output. So "How are you?" "I am good." Those pairs would be the training data for such a system. So we did an experiment to see if we could actually use such a system to train some kind of model that would generate text. So this system is actually used by Google Translate, for instance. So they used to have another system, but in the last couple of years they've completely changed it into this this recurrent neural network architecture. And we tried to do something similar where we would try to generate text. So the idea was that we wanted to have some kind of system that could do compression in an abstractive way. So compression means basically shortening a sentence. So you have a long sentence, you want to generate a short sentence. And one way of doing is by removing words from the sentence, because then it becomes shorter. But again, if you think about how humans do this, if I ask you to sort of do a summary of, for instance, Game of Thrones, you're not just going to take words from the book and then sort of make a compression out of that. You do an abstractive compression, where you try to abstract or make a summary in your own words. So we took a data set that we found that had these kinds of abstractions. And this is the MS-COCO data set, which is used a lot in vision research. And this data set contains pictures with a lot of sentences that describe the picture. And the nice thing is that you have longer sentences and shorter sentences that describe the picture. So you can actually think of the longer sentences and the shorter sentences as pairs, where you would have this is the original sentence and these would be compressions. So if you would put this into your system, you would hope that it would actually learn to generate shorter sentences. So we trained the model with around 1 million sentences, and then we just looked at what the output was. So here's the output actually of the system. So in blue, the originals. So these are the original sentences, and these are the generated outputs. So here you see the sentence, "A man flipping in the air with a snowboard above a snow-covered hill." And the generated sentence is, "A snowboarder is doing a trick on a snowy slope." So that seems to be sort of a compression of this. And you also see that the orange part is really an abstraction of this. Like a man flipping in the air with a snowboarder is doing a trick. They mean the same thing, but they are completely different. And this shows actually that the system has actually learned to sort of grasp the meaning of a sentence and then abstract it. There was also some interesting other stuff, like here you see a table with 3-place setting with meat, vegetables, and side dishes on it. It's translated or summarized into a tabletop place of food and a glass of wine. So this glass of wine comes out of nowhere. So does anyone have any idea why this system would actually add a glass of wine? Any idea? Because wine is delicious, yeah, that's true. So I guess the answer is that if you look at pictures of food, so if you go to Instagram and you just look at how people photograph their food, you will see that a lot of times there is a glass of wine on the side because wine is delicious. So the system has learned that a glass of wine is sort of something that also occurs together with food, so it has sort of hallucinated this glass of wine. So that was also interesting to see, and also an interesting, if you think about chatbots, also an interesting concept to think about. And the other one was also, this was also a very weird one, where a woman is leaning over a toilet while her arms are inside a lawn and garden. Flashback, a woman is cleaning a toilet in a park. Like, well, not really, but I can sort of see where it got its inspiration from. So I'll skip this. We did some evaluation and we saw that it worked pretty well. In fact, we actually saw that we had some kind of baseline system. We had the neural network and we had the human generated compression. And actually, we didn't see too much difference between the neural network and the human. So people were not really able to distinguish between the two. So then on towards chatbots a little bit a step further, basically. So we wanted to actually do this, but then generate responses as a chatbot would. And for that, we also needed data. So I also mentioned that you could use data from movie scripts or whatever. And we chose to use data from Reddit. So this is a big online community where people can post all kinds of links and stuff and then comment on it. And our idea was that every pair of comments could be seen as a sort of a micro conversation. So someone says something and then someone replies. So the task is then to try to generate a reply on any given input. So these are not really like full conversations, but just one-turn conversations, because you have to start somewhere. So we used a lot of data for that, 7.5 million pairs from 2015. And the nice thing of Reddit is that you can give scores. You can give scores to comments. So we filtered them on a karma score of higher than 5. So it meant that hopefully the comments had some quality in them. And we only took shorter comments. So we also did an evaluation on this, but we actually only took a sentence that had sort of a very generic meaning. So not the very niche things that usually you see on Reddit, like people discuss movies or television shows or games, but we only took generic ones. And there we saw that the neural model actually didn't do too well. And that is, I think that has something to do with the fact that, as I also already said in the beginning, these open domain systems are very hard to make. As we will see, it worked a lot better on closed domains. So here are some examples of outputs. I hope they are kind of readable. So in gray is the input and blue is the output. And what we saw is that actually the system worked really well on very specific concepts. One of them was memes, because they occur a lot on Reddit. Another one is television shows. So Game of Thrones was actually one that the system was very good, was very knowledgeable about. So here's one on Game of Thrones. Here's something like Tyrion was right in the show to tell her she isn't half as clever as she thinks. It's the worst when you think you're way smarter than you are. So this is about the character Cersei. And then the reply that is generated is, I think she's just a bit of a self-centered personality, which is kind of accurate, I think. And it also learned lyrics from songs. So if it would get the input "Baby, don't hurt me," it would output "No more." Television shows again from Top Gear. Some say he's still looking for this pocket to this day. All we know is he's called the Stick. Was the generated output. and a lot of memes, like I think this is a meme that it actually learned to, like this, how much should a collection like this be worth? About 350, which is a well-known meme. So yeah, we saw that this neural network is very good in generating stuff from very specific domains that are very that occur very frequently. So in this case, memes, television shows, and like games like League of Legends, which was popular at the time. It was very good at generating output for that. So this is one of the things that's been gathering some headlines lately. I saw it come by earlier, like this OpenAI who built this text generator. In the news, the news was that it was considered too good or too dangerous to release. I think that is a bit of an overstatement, a bit of a marketing thing. We are on our way of doing nice things in this natural language generation, but I think we're not there yet. So how can we use it? One of the problems is that you can't really use this technology if you have a client who wants to do stuff like this, because we saw in the Microsoft example, you don't want to have some kind of output that you can't predict beforehand. So basically what you can do is, and how we use it, is to help the user. So if you have to train a chatbot, you need to give it lots of examples. And one of the ways that we actually use it is to help the user by generating training examples. So here we took actually data from our own platform, so intents, 50,000 English intents, and we actually aligned pairs of examples within intents to be able to paraphrase input sentences into output sentences, which would help users to actually give more inputs for the chatbot. So this is what it would look like. So if you enter, like, can I order a pizza as an example of an intent, the system would then generate sort of paraphrases how you can also say this, and how you can add additional examples for your chatbot. So this is how it looks, what it looks like in the platform. So you say something like no, never. So this is typically an intent of negative inputs. And then the system just generates some examples. And you can add them if you like. So this really helps you if you have like a writer's block in coming up with examples. So yeah, to wrap it up, I think NLG at this moment you cannot really put it in production because it's not good enough. You can't really predict what it will output, but it can help you in actually training your bot. It can help, for instance, in assisting humans in customer service to give them suggestions. And I think we will go towards something like natural response generation, where you can also, for instance, generate buttons or generate images and these kind of things. And that was about it. So thank you.
Oh, thank you. Questions, comments, concerns? Okay, a double. This is great. When you're done, pass the mic.
Just quick, simple question. Just wondering, where do you see the technical hurdles for NLG? Is it because LSTM is not good enough, we need a better algorithm, or is it simply because we don't have enough data? And if you can, well, I guess you mentioned, but if you can perhaps give out some successful commercial cases, if there are any. Thank you.
Okay, yeah. So the question is, so what are now I guess the hurdles or the roadblocks? Why can't we really use this? I think one thing is data, because of course some companies have a lot of data, but not all the companies have so much data, and the format of the data is also a thing, because you need to sort of take into account what are good examples, what are not good examples. Another important part is actually that the technology right now is not so good in remembering larger parts of the conversation. Like, it can do stuff pretty well if you only have one, like if you do only one turn conversations, but if you do like multiple turn conversations, it gets really hard. And another thing is that it tends to over-generate for the very frequent examples. So it tends to generate the stuff that it has seen more often. Yeah.
So I was wondering, what's the minimum amount of data that you'd need for this type of technique? So for example, for a small business, could you use their Zendesk or something like that? Would that be enough information or enough data?
So how much data would you need to actually to train a generative model?
What's the minimum amount?
Yeah, that's really hard to answer because it depends on what you want to do. Like if you have like one process or one flow you want to automate, yeah, you don't need that much data. If there's not much variation in there, you don't need much data. But if there's lots of variation, lots of different flows, lots of different processes, then the amount of data it gets bigger and bigger. But I think you would need to think about like millions of examples to get something that's pretty decent. But again, you still only can generate then these one-turn things, or maybe two-turn, but that's about it. Yeah.
Okay, so a couple hundred, couple thousand, probably not enough, right?
It depends. Yeah, I can't really answer it without knowing the specifics.
All right, if you have other questions, definitely attack this guy outside. I mean, attack in the nicest way, right? Like you'd approach a bot conversation. Ladies and gentlemen, give it up for somebody who definitely has a lot of information for you.